We have a couple more examples that practice creating equations of lines that are either parallel or perpendicular to a given line. We just don't have the steps outlined here for us, but I think we can work our way through them. So let's start with example C. They tell us the point on the line that we're trying to write an equation of, and they give us a comparison line, and they say it's parallel. Our line needs to be parallel to this guy right here, and that ultimately we need to write our equation in standard form. So the first thing we're going to do is we're going to write in slope-intercept form our comparison line. So 2x plus 5y equals 10. We need the y alone. So we'll subtract 2x from both sides. And then we need to divide everything by 5. So our slope-intercept is negative 2 over 5x plus 2. So that's great. Now we've identified what the slope of our comparison line is. We need to determine what's the slope of the line we need to write. Well, we want a parallel guy, so we know our slopes are the same. So our slope of our new line that we're writing is also going to be negative 2 over 5. So that's nice. Now we need to go and we need to take the point that they give us on our new line and the slope and write our equation in point-slope formula. So that's y minus y sub 1, which is 6, equals the slope minus 2/5, x minus a minus 2, which is going to become positive 2. And if we could leave it in point-slope form, we'd be done. But of course, we can't leave it in point-slope form. We need to get it to standard form. So we're going to have to do some maneuvering to get it into the form that they're asking us for. So I'm going to do the distribution here, minus 2/5 x, and that would be minus, what, 4 over 5? Now I need to get rid of the fractions. So once I've got the distribution piece done, I can look for my common denominator, which is going to be 5. So when I multiply through by 5, I get 5y minus 30 equals minus 2x minus 4. We're almost there. Standard form, our x's and y's have to be together, so we'll add 2x to both sides. We'll write the x term first, and then we've got to get that 30 over there, that negative 30 over there with the other constant. So we're going to add 30 to both sides, and we get 2x plus 5y equals 26. So remember, standard form, not only do you have to have the x's and y's together, but the coefficient of the x has to be positive, which he is. That's good. And we can't have any fractions. So I think we're done with that particular problem. Let's go back up and look at this one. They're asking us to create a line that's perpendicular to this comparison line, and they give us a point on our new line. And they say they want it in slope-intercept form, but we're also going to go to standard form. More practice. All right, so our line, 4x plus 3y equals 12, is not in a format that we can determine what the slope is. So we need to solve for y. So we're going to subtract 4x from both sides, and then we're going to divide everything by 3. We get y is equal to minus 4 over 3x plus 4, and our slope is pretty easy to see now of our comparison line. But the slope of our new line that we're writing is a perpendicular line, so our slope needs to be positive 3 over 4. Now we're going to go and we're going to use the information that they give us. They give us this point. The point is 4, negative 5. Our new slope is 3 over 4. So we can write it in point slope or slope intercept form. No, point slope. Sorry, we don't have the y-intercept. So if we do that, we're going to say y minus y sub 1, or y minus a minus 5 makes plus 5, equals slope of our new line, x minus 4. So that's great, and if they let us leave it in point slope form, we'd be finished. But let's transform it into standard form, and we get y plus 5 equals 3/4 x, do the distribution, minus, let's see, what does that end up being? Minus 1. I think I might have done this wrong when I did it last night. Let's take a peek here. And now we need to clear our fractions out, multiply through by 4. 4y plus 20 equals 3x minus 4. Get your x's together. So we're going to subtract 3x from both sides. And we're going to subtract this 20 to move him over here. And we're going to get minus, that would be minus 24. We're almost finished, except this 3 cannot be negative. This coefficient has to be positive. So we're going to have to multiply through by negative 1. 3x minus 4y equals positive 24. I hope I did that right. If I didn't, I'm sure you guys will tell me. Okay, let's look at these last two special examples. These are individual lines that don't have an x with them. So if this line, y equals 5, if you were to go sketch it, it would look like this. 1, 2, 3, 4, 5. It would be a perfectly horizontal line through positive 5 on the y-axis. Well, the line that we're going to create is going to be parallel to him, so he is also going to be crossing through the y-axis. However, he's going to cross through at negative 7. Here's our new line. And standard form, any kind of form you want to write it, it's y equals negative 7. Let's look at this one. This is saying it wants a perpendicular line to the same y equals 5. Again, I'm going to sketch y equals 5. Here's y equals 5, the perfectly horizontal line. It needs to be perpendicular to him, so it's going to pass through negative 1, 4, right here, and it is going to be this guy right here, which is going to be x equals negative 1. This is making a 90-degree angle. These two guys are parallel. So E and F are special examples, again, of those lines that are perfectly horizontal or perfectly vertical, and their format is just a little bit different. Thanks for watching.